Hello, can you hear me? Can you hear me? Okay, so I will today we will do AC generator. Okay, I hope you have seen the videos that I gave for alternating current. Good afternoon, everyone. Today we will do AC generator. Okay, uh, so to produce AC current I have discussed in that video lectures that I uploaded in YouTube. So to produce that, we need a AC generator, right? So what is a AC generator? It is a device. It is a that device that can convert mechanical energy to electrical energy. Okay, so AC generator is a device that can convert mechanical energy to electrical energy. Is it clear so far? Any doubts so far? Any doubts, please type in the comment box. Is it clear so far? Any doubts? Okay, so AC, that is an AC generator. Let me show you what it looks like. So this diagram is the diagram for AC generator, right? You have this these are magnets pole pieces, you can say. The one marked with red is north, this is your south. So, and you know direction of magnetic field is from north to south. Inside this magnetic field there is a coil, this is also called armature, right? And now this coil is connected to this red coils. These are called your slip rings, SLIP RINGS, slip rings. And now these red coils are connected to brushes. Okay, these are called brushes. Okay, and now this whole thing is connected to an output where you can receive the final thing. Is it clear? Understand? We have magnets, we have armature which is made up of a wire in the shape of a rectangle, right, and this is connected to slip rings, slip ring is connected to brushes, and then the whole thing is connected to an output where you will receive this type of output. It can be current or voltage, right. Any doubts? Any doubt? Any doubts? Yes, any doubt so far? What are the parts and all of a AC generator? Is it clear? Please reply in the comment box so that we can proceed ahead. Parts of AC generator is clear. What is armature? What are slip rings, brushes? Okay, so that is how a AC generator looks, right. Now how does it work? Principle of working. So AC generator, it works on the principle of electromagnetic induction. It works on the principle of electromagnetic induction, which we have already studied. What does it mean? It means that if there is a changing magnetic field, if there is a changing magnetic field or magnetic flux, then an EMF is generated, right. This is what is electromagnetic induction. Yes or no? We have talked about this chapter. We have done this chapter in the last the last chapter that we did was about this, right. So that is electromagnetic induction, and that is how a AC generator works. So in here there is a coil which has an area. Let us say the area of this red coil, if you can see inside, is A, right. Let us say that the magnetic field B produced by these two magnets, north and south, is B. Now we know the formula for magnetic flux phi is BA cos theta, right, where theta is the angle between magnetic field B and area of the coil A, right. So this is the theta. Okay, so now what happens here? Magnetic field is constant, right. It's not changing because we are using the same magnet, so it's same. And even area of the coil you cannot change, the shape is same, so area will be same. But what is different here? Theta will go on changing as the coil rotates, as the coil is made to rotate, right. The area, the angle between B and A changes. So because of this phi also changes, and now when phi changes you get EMF. Why? Because the formula for EMF is minus d phi dt. This is from Faraday's law, right. Yes or no? Is it clear so far? Okay, is it clear how EMF is produced? So that is how EMF is produced in a AC generator. Okay, now EMF, I'll repeat once again. What is EMF? What is the meaning of EMF? EMF, it stands for electromotive force. Electromotive force. But remember that this is not a force. This is not a force, right? Even though there is a word force in the name, it is not a force. It is a voltage or a potential difference. It is like voltage or potential difference, and because of this potential difference you get current. Whenever there is a potential difference you get current, and in this case we call this induced current. Okay, so EMF is clear. What is EMF? EMF is not a force, it is a voltage that can produce current, right? It is a potential difference. Okay, so let me just erase that. Now one thing I would like to explain to you, this is from class 11 in fact, but let me just, right, if you have a circle like this, right, suppose you have a circle, and now let us say an object is moving on the circle, right? Object is moving on the circle and it is moving with angular. So we talk about velocity, right? Velocity, we say velocity when object is moving in a straight line, or it is moving in a straight line. But when the object is rotating, we don't say velocity, we talk about angular velocity. Angular velocity, right? When the object is rotating about something, right, it's moving about something, like in this case this is the center, so the object is moving about the center. In that case we don't talk about velocity, we talk about angular velocity, and that is given by omega. So the symbol for angular velocity is omega. This is the symbol. And what is the definition? Just like velocity, we know velocity is equal to rate of change of position, dx dt. Yes or no? If an object moves a distance dx in small time dt, then that is the velocity. Velocity is dx by dt. But in case of angular velocity, it's not the distance, we talk about angle. So how do we define omega? Omega is equal to d theta by dt, rate of change of angle, right? So this angle, if the object covers a distance d theta, small d theta, in time dt, then the angular velocity is d theta by dt. Okay, and in the same way, if the angle is theta and the time it takes is t, then omega will be equal to theta by t. Is it clear? Is this point clear? This is very important. If it's not clear, I'll repeat once again. Please tell me. Yes, please tell me quickly, is it clear? Okay, so angular velocity, I'll just explain angular velocity once again. Suppose I have a circle and then this is the center of the circle, right? Suppose I have an object here, object is here suppose, and this object is moving in the circumference of the circle, right? So in this case I will not talk about distance, I will talk about angular distance. That means how much angle is it covering in how much time, and that will give me angular velocity. Just like when I have a straight line and an object is moving here, right? Suppose I have an object moving in the straight line and it covers a distance, suppose starts from time 0 and position 0. It starts from position 0, time 0, and after a time t it covers a distance of x, let us say, right? So what will be the velocity? Velocity will be, you know, the formula for velocity is change displacement divided by time. So what is the displacement? This final position minus initial position. So final position is x, initial position is 0. So x minus 0 divided by final time minus initial time, t minus 0. So the formula for velocity is this, right? In the same way, when object is covering a moving around a circle, I don't talk about distance, I talk about angle, right? So suppose this object is here now, and after some time it reaches here, right? So let us say this is the position P, this is position Q. So now let us say the angle here is theta, and the angle from here to here is theta plus d theta, right? Angle here is theta, angle okay, let me call this OA. So angle AOP is theta, angle AOQ is theta plus d theta, and the object moves from P to Q in time dt. The object moves from P to Q in time dt. So that means what will be the angular velocity? It will be final angle minus initial angle. So final angle is theta plus d theta minus initial angle. Initial angle is theta, final time. So time, how much time did it take? D theta or dt, sorry, dt. So the formula will be d theta by dt. This is called angular velocity. Okay, this is angular velocity, the rate of change of angle. Okay, understand? When object is moving around a circle, it's easier to talk about the angle that has moved. That will tell us how fast it is moving. Is it clear? Yes or no? Now is it clear, omega? It's clear now? Okay, so that is what is angular. So this is the definition for angular velocity. Okay, now let me simplify this. Let me simplify. Okay. So let us say the object starts from here. So the angle here is 0, and after some time it reaches this point here. It reaches this point here, and How much time does it take to go from here to here? Let us say it takes time t, and the angle is theta, right? So I am saying the object starts from this point here, let us call this point A, and this point let us call it B. So object starts from A, that means the angle here is 0, yes or no, because this is the line with which we measure the angle. So this angle is 0, and after a time t it reaches B and it makes an angle theta. So using the formula for omega, what do we get? Theta minus 0, final angle minus initial angle, which is 0. Final time, how much time did it take to go from here to here? T. So t. So formula for omega can be written as theta by t. This is this clear? So theta by t is the formula for omega, right? So that means theta can be written as omega t. This part is clear? Okay. Now even this coil here, even this coil, this red coil that you see inside this magnet piece is moving in a circular motion. You will not be able to I mean see it now, but if I show you this animation, just look at this animation and you will see. Can you see this coil? Look at this coil, it's moving in a circular motion, right? It's moving in a circular motion, yes or no? Look at these two arrows, these two black arrows on the coil. Can you see they are moving in a circular path, right? So this is how it works. Okay, magnetic field is here and this coil moves, and because of that this thing moves, and then you can produce EMF. Okay, is it clear? Okay, so even this coil here is moving a circular path, and let us say again this is also moving with angular velocity omega. Let us say the angular velocity of this coil is omega. So and it covers angle theta in time t. So theta will be equal to omega t, right? Here also, so we can substitute this in this formula for phi. Erase everything. So in this formula for phi, instead of theta I can put omega theta, right? So theta will be equal to BA cos omega t. Is that part clear? How phi is equal to BA cos omega t? Is this clear? Okay. Now so this is phi is equal to BA cos omega t. Now I told you, as the coil is moving in this magnetic field, your phi changes because the angle is changing, continuously changing, right? We will see that later, but it is changing, and because of that change you get an EMF. The formula is minus d phi dt. So we'll put this value of phi in that. So EMF produced, EMF generated is equal to E is equal to minus D. What is my phi? Phi is BA cos omega t divided by dt, right? right. So this is the formula for the EMF that will be produced. Now let us differentiate this. I hope you know a little bit of differentiation from maths. Okay, so now so B is constant, it will come out, minus is there, B is constant, comes out, area is constant, that will also come out, rest of the things will stay inside. So you will get d dt cos omega t, right. Now what is the, now you know from differentiation d dx of cos x is equal to minus sin x, right. You know this from the formula of differentiation if you have done this part in maths, right. So we will use that here. So I will get minus ba, so this will give me minus sin x, here is omega t, so it will be minus sin omega t, but this is, so see this is t but this is omega t, so there is extra omega, so for that I have to do chain rule. So I will get d dt of omega t also, right. This part is clear so far. Yes, Sujata, what are you asking, how it came? Please ask specifically. Okay, phi is equal to omega t. So I have explained here. So angular velocity formula is clear, that if I have a circle, an object is moving on this circle, let us say starts from here, let us say this is A, and after a time t it reaches this point B here, okay, and let us say that the angle at B, angle AOB is theta, then that means formula for angular velocity omega, so omega will be equal to, what is the change in angle, final angle theta minus initial angle here is at A is 0 divided by time. How much time did it take to go from A to B? Let us say it takes time t. So the formula will be omega is equal to theta by t. So from here if I just cross multiply, I will get theta is equal to omega t, right. Same thing is happening here also, this is also moving in a circular path, right, as I have shown you in the animation. Okay, so same formula we will use, we will say that the angular velocity of rotation is omega, that means the coil is moving with a rotating with the speed of omega. So from here we will get theta is equal to omega t. Okay, this part is clear. So now, so instead of theta here I will put omega t, so that is what I did here. So phi is equal to ba cos omega t, okay, from here, this is coming from here, okay, and then the rest of the thing I think is clear. Okay, so now moving ahead, so till here is clear, differentiation is clear, this part differentiation is clear. How I got EMF E is equal to this part is clear or not? Till here it's clear. We have not completed here, I am in the way, right? So is it clear, that part? Okay, now going ahead, so continue, right? So E will be equal to minus BA, and I have a minus sine omega t. Now differentiation of this, again omega is a constant, it will come out, so I will get dt dt, right, ddt of t. Okay, so minus minus gives me plus, so that will become BA sine omega t, and ddt of t is 1. Okay, so into 1, so the EMF that you will get is BA sine omega t. Is it clear? Is it clear how I got this? Okay, now so this is the EMF that you will get in this coil when you put it in a magnetic field whose value is B, and if the area of the coil is A, then the EMF produced will be BA sine omega t. So here we are taking a coil which has only one turn, right? If I use many turns, right, let us say the number of turns is n, number of turns, if number of turns of the coil is capital N, right? In that case your formula for E becomes NBA sine omega t. So this is the EMF that will be produced in the coil if you have a coil whose where number of turns is n, and if you put that coil in a magnetic field B, and if the area of the coil is A, then the EMF that will be produced in the coil because of the rotation is this one, right? Now this NBA is a constant, NBA is a constant, N is constant, B is constant, A is constant, and this constant is E naught, maximum EMF. Maximum EMF that will be produced, right? So this is, so you can write E is equal to E naught sine omega t. Right, is it clear how I got E is equal to E naught sine omega t? Is that part clear? There are 2 omega. Okay, I think yes, sorry about that. Yeah, so one more omega is there, right? So this will be omega here, omega BA, right? So all these are constant, NBA omega, right? So there is one more omega, okay? Please take care of that. So because from here we will get omega BA and all that. Okay, all these are constant. NBA omega is a constant, so that is your maximum EMF generated. Is it clear now? How EMF E is equal to E naught sin omega t, is that part clear? Okay, this diagram here will explain things better. Okay, now look here what is happening. So this, you can see this is the coil, PQRS is the coil, and the magnetic field is shown with this black arrow B, right? And so you know what is the direction of area? Area is perpendicular to the coil. Okay, so in this case you see direction of B and A is same, that means your angle is 0. Okay, omega t remember is the angle theta. Okay, so since, so you, okay, I'll just explain this once again. If I have area, then the direction of area is perpendicular, that means this one, right? If your this one, then again coming out perpendicular, right? You have to imagine this. Okay, in the same thing here, PQRS is along the direction of magnetic field, so that's why your angle omega t theta is 0. Okay, and now the coil will rotate, so the coil will rotate, and now it is reaching. Now look, magnetic field, the direction of magnetic field is always same. Okay, it's the coil that is moving. Okay, so now the coil will rotate by pi by 2, so that's why theta will be pi by 2. Okay, if you put 0, so omega t equal to 0, in this case if you put in the formula, if you put it here, right, omega t equal to 0, so E will be 0, sin 0 is 0, so that's why you can look in this graph, E, this is the graph between E and your omega t. So that since omega t is 0, so from this formula E will also be, so this is capital E, you can say, right? So this capital E is 0, and now suppose the coil rotates by 90 degree, omega t will be pi by 2. So if you put pi by 2 here, you will get E naught maximum, so that occurs at this one, right? So this is your maximum E naught. Okay, after some time the coil will rotate by pi by 2 once more, so total angle will become pi, sin pi is 0, right? So again this will become 0. Now next it will rotate by pi by 2 again, so this will become 3 pi by 2. In that case sin 3 pi by 2 is minus 1, so E will become minus E naught, so it will be E naught but in the negative direction, so this will become minus E naught here, right, minus E naught. Okay, and finally again it will rotate by 2 pi, total angle, that means it will reach the same point as this one, right? In that case again sin 2 pi is 0, so this is how your EMF is produced. If you have seen the videos that I have put for alternating current, you will see we get the graph between E and omega t, or I and omega t is like this, and this is how it comes. Is it clear? Is it clear how EMF E is produced? Yes, EMF is clear. Any doubts? Any doubts? So just to give you a recap, so you have a magnet piece here, north south. Inside this magnetic piece there is a coil shown with red color here, and this coil is connected to the slip rings, these circular rings, and the rings are connected to brushes. Okay, so what is the job of these? This helps you to connect the output, to get the output. Okay, the job of slip rings and brushes is to give you an output. Okay, so you can see, so what happens as soon as a magnetic field operates, this coil will rotate, right? And when this coil rotates, your theta changes. Theta changes in this formula for phi. In this formula for phi, theta changes, and if theta changes, phi will change, and because of that change, EMF is produced because of the formula minus d phi dt. So, and I have shown how theta is omega t. So, using that, if I put in the value for EMF, I will get this answer E, right. So, it is very simple if you understand like that. And now, this one shown in the diagram, this is your output, right. This is the output that you get. This is the output that is produced. Okay, any other doubts? Okay, so that is how AC generator works. That is how we get alternating current. And what is alternating current? I have discussed in that video that I gave. You just have a look at that. AC current is the current that changes magnitude continuously and whose direction reverses periodically, and that is what we receive at our home also. And if you want to change it to DC current, then we have to use devices. Is it clear? Right, now I think if you have understood this, then if you look at the chapter for alternating current, the videos that I have gave, you will understand it much better. So I want to do numericals in the next live stream. Just tell me which chapters, I mean, you want to do numerical from which chapter? So we will discuss the numericals of that chapter. Kirchhoff's current law and voltage law, we have not reached that chapter. That is current electricity. I have not even done that chapter. Tell me something that we have done the chapter. Okay, if you have done that chapter, Kirchhoff's law, current law, you can ask me separately. Okay, we can conduct a separate video class on that, and I'll help you if you need. Just WhatsApp me what doubts you have. WhatsApp me separately, and then I will check, and then we can discuss. Yeah, so is it clear what we did today? If it's clear, then I will end the stream here, and then we will meet again maybe next time. Just WhatsApp me what doubts you have. Use of Biot-Savart law, application of Biot-Savart law. I think I have done that circular one. You just have a look at that. I cannot show you here, but I think we have done that circle one, if you remember, where we found the magnetic field at the center of a coil, right? If I have a coil like this, then what will be the magnetic field at a point P from this? That is application of Biot-Savart's law. If you see, I have written there also. solutions. Do you have any numerical problems that you are doing? If you are doing any numerical problems and you are not getting the answer, you can send me those numerical problems, then I will give you the solutions. Okay, let's do numericals on magnetism. Then tomorrow I will find some numericals on magnetism, and let us discuss that. But those who have not studied anything about magnetism, read it and come to the stream, otherwise you will not understand anything. Okay, we will discuss the questions that came from magnetism tomorrow. Okay, I will try to find some questions that came last year or last 5 years. What are the questions that came from the chapter, and we'll discuss that. But make sure you read and come, otherwise you'll not understand anything, because I will not explain from the basics. I will just answer the questions that have been asked. Okay, so I will